Good afternoon, ladies and gentlemen. You should be in Mrs. Richards' room with Mr. Hartley right now. I am at Cedar Point with our physics and calculus students today. So we'll go ahead and have this video to fill in your notes. Hopefully Mr. Hartley has collected your homework from Friday. Remember, that homework from Friday was your dividing radicals worksheet A. So he should have collected that. And he should have passed out your notes to you so you could fill them in. So we will go ahead and get started. Basically today we are going to be doing the second day on dividing radicals, which we started on Friday. So if you would please fill in your warm-up. By now you should have no doubt what a perfect square is, and you should be able to list those first 20 perfect squares. So go ahead and pause this video and fill in the top part of your notes. Please remember that the perfect squares that you are going to use are the circled numbers. All right, again, this portion of your notes should also be familiar to you. When multiplying and dividing radicals, you should know that you do not need like radicals to combine. It's just like if they were variables, folks. When you are multiplying and dividing, you do not need them to be the same. Please remember, when you are dividing, you cannot leave a radical in the denominator. Okay? It's kind of like when we were doing exponents and you couldn't have negative exponents. You cannot leave a radical in the denominator. Remember, the denominator is the bottom of the fraction. In order to fix a radical in the denominator, you must do something called rationalizing. Okay? You are going to rationalize it. This means to multiply the numerator and the denominator by the radical in the denominator. And then when you're done with that, you're going to have to do some simplifying. So we're going to start off nice and easy, and then we'll finish with some more difficult ones, and then I will finish up with some reminders of how to multiply as well. All right, here we go. It says simplify to give an exact answer. Remember, exact means no decimals. So you can't just type this into your calculator and give me a decimal. All right, so number one, you see we have this radical 5 in the denominator. We can't have that. So we need to rationalize it. And up in that directions there, it says you need to multiply the top and the bottom by the radical that's on the bottom. So we will multiply top and bottom by radical 5. All right, so up top, we have 3 times radical 5. Well, 3 is a coefficient. It is not under a radical, so that stays out front. The radical 5 is being multiplied, so it stays right next to it. Now on the bottom, you have radical 5 times radical 5. Well, they're both under the radical, so 5 times 5 is 25. That is underneath the radical in the denominator. Well, 25 is a perfect square, so we can simplify that to be 3 radical 5 over the square root of 25, which is 5. Now, the last thing you need to do, folks, is you need to see if you can reduce this fraction? You are only looking at the numbers that are outside of the radical. Does 3 over 5 reduce? And that answer is no. So we are going to leave our answer just the way it is, like that. And notice there's no more radical in the denominator. It's okay to have a radical in the numerator. All right, number 2. This time you see that the radical is over the entire fraction. Well, if that's going to happen, you can write this a little differently. This is the same as having radical 7 over radical 8. All right, we'll take a look. I've got a radical 8 in the bottom, and I don't want to have that. So we're going to multiply the top and bottom by the radical 8. In the numerator, the 7 and the 8 are both under the radical, so multiply them together. You get radical 56 on top. And on the bottom, you get radical 8 times radical 8, which will be radical 64. Now here's where the simplifying comes in. We need to see if we can take anything out of these radicals. Well, the bottom is perfect square. Square root of 64 is just 8. Now, 56 should have a perfect square that can be divided out. Can you find it? Remember, we're on your calculator, you're doing 56 divided by, and you're trying to find a perfect square that will go into there. It looks like 4 will go into there. It's 4 times 14 to make 56. Well, 4 is your perfect square, so that needs to come out, and the square root of 4 is 2. 14 is left underneath, and we still have that 8 in the denominator. Take a look at your coefficients. That is able to be reduced. 2 eighths is the same as 1/4. Now, you don't have to write the 1 up top. It's assumed to be there, but there would be a 4 in the denominator. Notice, the whole point here was to get rid of the radical on the bottom, and we did that. All right, number 3. You see the radical on the bottom is 24, so we need to rationalize. Up top, the 9 is a coefficient that stays out front. The 3 and the 24 are both under the radical, so we can go ahead and multiply those, and you get 72 underneath the radical. On the bottom, both 24s are under the radical. You multiply that, and you get 576. Now, 576 is a perfect square. The square root of 576 is 24. And now we need to find a perfect square, the bigger the better, that will divide out of 72. Well, 72 is divisible by 36. That's 36 times 2. So the 36 is your perfect square. The 36 will come out, and that will come out as a 6. But remember, there's already a 9 out there. So multiply it by that 6, and it will look like that. All right, 9 times 6 is 54, and we have a 24 in the denominator. So let's reduce it. What's the largest number we can divide both 54 and 24 by? They are both divisible by 6. So we are reducing this portion right here, and we're going to divide them both by 6. If I divide by 6, 54 divided by 6 is 9. Notice we're leaving the radical 2 alone, and 24 divided by 6 is 4. And that will be your final answer. Looking at number 4, you see we have multiplication going on here. Well, you know how to multiply. Both of those numbers are under the radical, so go ahead and multiply them. If you take 3 3/7 times 2 1/3, you will get 8. So this thing is just radical 8. Please notice, you don't have a fraction with a radical on the bottom, so all you need to do is simplify that radical 8. And hopefully you know by now that radical 8 has a perfect square of 4 that can be divided out. When you take out this perfect square of 4, it becomes a 2, and the 2 stays underneath for a final answer of 2 radical 2. All right, flipping over to the back, folks. Number 5, notice we have that radical 35 on the bottom. We need to rationalize it. out by multiplying the top and bottom by radical 35. The 6 will stay out front. Multiplying 7 and 35 will give you 245. And on the bottom, radical 35 times radical 35 gives you 1225. Now I hope you're realizing by now that when we multiply in the bottom, it's always going to give us a perfect square. So go ahead and take the square root of 1225, and you should see that that is 35. Now in the numerator, what perfect square can we take out of 245? 245 is divisible by 49. It's 49 times 5. 49 is the perfect square. The square root of 49 is 7. So that comes out and gets multiplied by the 6 that's already out there. And the 5 stays underneath. 6 times 7 is 42. And now all that's left to do is reduce these numbers. Both of those are divisible by 7. 42 divided by 7 is 6. And 35 divided by 7 is 5. Please notice that you don't touch that radical in the numerator when you're simplifying. Take a look at number 6. This time we have a 39 under the radical in the denominator. So we will rationalize it. The numerator has the 5 out front. 48 times 39, yikes, that's a big number, is 1872. In the denominator, you get 1521, but remember that denominator is normally always going to be a perfect square. And that, when you take the square root, will give you 39. So now the question becomes, what's a perfect square I can take out of 1872? So grab your calculator. 1872 divided by, let's see here. Remember, the bigger the better, folks. $36 will work. It's 36 times 52. Well, 36 is the perfect square. The square root of 36 is 6. So now I'm looking at this. 5 times 6 is 30. But I think there's still one more perfect square that can come out of 52. And that should be 4. 4 times 13. 4 is your perfect square. The square root is 2, so that comes out. The 13 stays underneath. And it looks like that. Finally, 30 times 2 is 60. Radical 13 over 39. And the question is, can we divide both of those by something? Well, they both are divisible by 3. 60 divided by 3 is 20. And 39 divided by 3 is 13. So folks, you can see that some of these are starting to have lots and lots of steps. That's fine, you just got to keep them all straight. All right, number 7. Notice that that fraction is entirely underneath the radical. So we can rewrite it like that. I hope you realize that 9 in the bottom is a perfect square. Please also notice that the 3 is going in the numerator, folks, because it's like a 3 over 1. So the 3 would be in the numerator. The square root of 9 in the denominator is just 3. And notice 3 over 3 will cancel. So all I need to do is simplify that radical 48. What perfect square can divide into 48? The biggest is 16. Square root of 16 is 4, and the 3 is left underneath. All right, last one with the dividing here. Again, same idea. The 7 is in the numerator. Both of those under the radical can get their own radical. Separate them. Please notice that 49 is a perfect square. square root of 49 is 7. And the same thing happens. Those 7s cancel. And all I'm left with now is a 40 under the radical. What perfect square can divide into 40? 40 is 4 times 10. 4 is a perfect square. So the 2 comes out, and the 10 is left underneath. All right, folks, these last 4 problems across the bottom are just making sure you remember how to do multiplication with radicals. So, remember, we multiply the coefficients. We multiply what's under the radical. And now we need to simplify. 75 has a 25 in it. 25 is a perfect square. The square root of 25 is 5. The 3 stays underneath. 12 times 5 is 60. Radical 3. Same idea, number 10. Multiply your coefficients. Multiply what's under the radical. This one looks pretty good. What's under the radical is a perfect square. The square root of 25 is 5. So it is being multiplied by that negative 12. And you get a final answer of negative 60. Number 11, no coefficients. These 2 numbers are both under the radical, so multiply them. And you're going to get a nice whole number of 9. 9's perfect square. Final answer, the square root of 9 is 3. And finally, no coefficients in number 12. So multiply those numbers under the radical, and you will get 180. What's the biggest perfect square you can divide into 180? 36 times 5 is 180. The square root of 36 is 6, and the 5 is left underneath. So those are your notes for today, folks. Your homework is a worksheet. It's called 10-2 Dividing Radicals Worksheet B. Mr. Hartley should have that for you, so go ahead and get that from him when you're done copying in your notes. And I will see you tomorrow.